Hello everyone. In the previous video, we had seen the third lab component of digital design and computer organization. There we had seen adder circuits. Today we are gonna see the subtractor circuits. Here we'll see half subtractor first. In half subtractor, we'll have two inputs x, y and two outputs borrow, output and difference. Here always we'll subtract x minus y. When we subtract 0 minus 0, we get 0 and borrow out we'll have 0. 0 minus 1 cannot be computed, so we'll take borrow as 1 and the difference will come as 1. When we subtract 1 minus 0, we get the difference 1 and the borrow will be 0. When we subtract 1 minus 1, we'll get the difference 0 and borrow as 0. After seeing the truth table, we can write the difference and borrow out equations. That is, the difference equation will be xy bar plus x bar y and borrow out equation will be x bar y. Difference equation can also be written as x XOR y, which is XOR equation for two variables. We are implementing these two equations in logic gates. X and y are our two inputs, A and B are two NOT gates, G1, G2, G3 are three AND gates, G4 is OR gate. From X, we take one input to gate 1 and Y is taken to gate 1 through an OR NOT gate, which makes this input as Y bar and this input from X goes as it is. The output comes out of G1 as X Y bar. Similarly, in gate 2, we send Y as it is and X is sent through the NOT gate and we get the output X bar Y out of the gate 2. We send these two outputs into the inputs of gate 4. We get the difference equation, that is X XOR Y. Instead of all this lengthy computation using so many gates, we can use a single XOR gate, which makes our logic circuit look simpler. And for borrow out equation, we'll take X bar from here directly as one of the input for gate 3 and Y comes as it is to gate 3 as second input. Those two gets computed in gate 3 and our borrow out equation will come as X bar Y. Now let's see full subtractor design. Before that, we'll see why it came to the existence. Here, while taking this subtraction as an example, we are subtracting this number from this number. That is, 1 minus 0 will be 0. 0 minus 1 cannot be computed, so we take a borrow and here we get 1. We can't compute 3 inputs, so we got full subtractor into existence. As in half adder, half subtractor, we get the same type of table. We'll get the equations of borrow and difference by using the K-map. In K-map of borrow out equation, we'll get 3 pairs, and in difference we don't get any pair, so we circle them as it is. And difference equation, we get it as x bar y b in plus x bar y b in bar plus x y bar b in bar plus x y b in, which is nothing but our 3-input XOR gate equation, that is x XOR y XOR b in. For borrow out, we get the equation as x bar b in plus y b in plus x bar y. We implement the same in logic gates. Here we take x, y as 2 inputs for XOR gate, that is G1 gate, and we get the output to gate 2's first input, and B in is taken as second input for gate 2. Then we get the difference equation as x XOR y XOR b in, and here we have taken one more NOT gate to compute x bar, and we calculate x bar by this. From here we take the inputs. We take one of the x bar to gate 3's first input and y to the second input for gate 3, and we get the output at x bar y. We take it as one of the input for gate 6. We take x bar as one of the input for gate 4 and b in as the second input for gate 4, and the output will come as x bar b in. We take this output to the second input of gate 6. And for gate 5, we take y as one of the input and b in as second input, and the output will be y b in. We take these two inputs, that is x bar y and x bar b in, to the inputs of gate 6, and the output is taken to one of the input of gate 7. The one more output, that is y b in, is taken as another input for gate 7, which gives us the b out equation, that is x bar b in plus y b in plus x bar y. Now let's see the Verilog codes. Here we have discussed Verilog code in the second question only. As same, A is one of the input, B is input, sum, and CAR is nothing but our carry, DIF is difference, BW is borrow. These are all these two are inputs and these all are our outputs. Inputs we have listed AB, and outputs also we have listed carry, sum, difference and borrow. For half adder, these two set of instructions get computed and our half adder value will be shown, and for half subtractor these two will do the work. And we'll get the output as here. Okay, and full adder and subtractor Verilog code we'll see now. The same way, here we have 3 inputs, so A, B, C are the 3 inputs. Sum, carry, difference and borrow are listed here. Inputs are A, B, C, outputs are sum, carry, difference and borrow. These two lines we get the full adder, and these two are for full subtractor, and we get the output as this. Thank you. And in the next video, let's see the fourth lab component of digital design and computer organization. Thank you.